Hello, this is a lecture on time response of first order system, the continuation of time response of first order system. Okay. In the previous lecture also we have seen the time response of first order system under unit step input, but in this case we will see find the time response of first order system under unit a ramp input solution. We know the first order standard form of first order system is equal to what? C of s divided by R of s equal to 1 by Ts plus 1, T equal to time constant. So we know C of s divided by R of s equal to 1 by Ts plus 1, T equal to time constant, and R of s equal to what? 1 by s square. It is called unit ramp input. Okay. So now I'll substitute one by s square. Okay. What I supposed to find? C of t, time response of first order system. C of t. Now C of s is there. How to convert C of s into C of t? I have to take what? Inverse Laplace. But inverse Laplace, the term should be what? Addition form. Now multiplication form. How to convert the multiplication form into addition form? By using partial fraction. So there are three formulas for partial fraction. For example, suppose x plus 2, x plus 3. The highest power of x is 3. So that 3 constants. So ABC are 3 constants, x plus 2 and x plus 3. Suppose if it is x plus 2, x square plus x plus 2, then the highest power of x is 3. So that 3 constants are required. Once again ABC, but in this case the way of writing is a by x plus b by x square plus c by x plus 2. And one more is x into bracket x plus 2, that is a by x plus bx plus c divided by x square plus 2. Now in this case I have to apply second formula to find ABC value. You find here also the highest power of s is 3, so that you find ABC value. Now what I'll do? So I'll write 1 by s square plus ps plus 1 equal to a by s plus b by s square plus c by ts plus 1. I'll take a LCM s square t plus 1, s square t plus 1. So here 1, here s into bracket ts plus 1, ts plus 1, s. Here 1, as ts plus 1 plus b ts plus 1 plus cs. Now 1 equal to at s square plus as plus bts plus b plus cs square. Now I'll take s square coefficient one side and s coefficient one side. And here no s square coefficient, no s term, so that I'll write 0s square plus 0s plus 1. Now I'll compare the coefficients to find ABC value. First I'll compare the constant coefficient. B equal to 1. Next I'll compare s coefficient. A plus bt equal to 0. So a plus b is 1, t, a equal to minus t. Correct? Now you take s square coefficient, at plus c is equal to 0, then a is minus t plus c, c is equal to what? T square. Now I'll write, what I'll do, I'll put ABC value. Then I'll take a inverse Laplace. So you put ABC value, A is minus t, B is 1. And C is t square. So how to find ABC value now? C of s equal to a by s plus b by s square plus c by t s plus 1. You have substituted ABC value. Now you have to take inverse Laplace. But before taking inverse Laplace, some modification is required. Just you see that Laplace of e raised to minus at is equal to 1 by s plus a. So Laplace inverse of 1 by s plus a is equal to what? E raised to minus at. S coefficient should be unity. Here s has t, so that to divide numerator and denominator by what? T. So t divided by s1 plus t. Now you take a inverse Laplace. Whenever I will take a inverse Laplace, now what happened? 1 by s square plus t inverse Laplace of 1 by s plus 1 by t. Now here c of t, here minus t, 1 by s is 1 plus t, because Laplace of t equal to 1 factorial divided by s square, and Laplace of s square 1 by s square is equal to t divided by 1 factorial, that is t, plus Laplace inverse of s square is how much? T square by Laplace inverse of 1 by s is 1. Laplace inverse of 1 by s square is t, correct, plus t e raised to Laplace inverse of 1 by s plus a, t e raised to 1 by t. Capital T is a time constant, small t is the time in second. This is what time response of first order system under unit step input, under unit ramp input. Now we will draw a graph of this C of t response, output, time response, or a response, or a output. Now we will draw a graph. How to draw a graph? You put, is it passing through origin or not? You have to check. T equal to 0, C of t equal to minus t plus 0, e raised to 0. That is what? 0 plus t into 1, that is 0. When t equal to infinity, C of t equal to minus t plus infinity plus t raised to minus infinity, that is minus t plus infinity plus t by infinity, that is 0, and infinity something is nothing but infinity. And the sufficient t is equal to time means what? It is a sufficient time. Okay. So now after sufficient time it goes to infinity. All the values goes on increasing with respect to time. If I draw the graph, it's a time in second, and this is r of t, r of s equal to what? 1 by s square, unit ramp input, or r of t equal to t. R of t equal to t. Correct? Because Laplace of t is 1 by s square. Now I will draw a c of t. You see here c of t is exponential, so that this is what c of t curve. So here y-axis is both input as well as output. Now after sufficient time I can see the error, after sufficient time, what is the steady state error? Already we have seen in the previous class. What is the steady state error? Error after sufficient time. We will find a error, steady state error. ESS is equal to limit S tends to 0. This is a formula for steady state error. The difference from input to output. Input to output. After sufficient time, t equal to infinity means S is equal to 0. I know here S is equal to 0. S, what is the R of S? 1 by S. Is it right? So what is the C of S? Before partial fraction I have written C of S. Now I will take a LCM. So I will take LCM S square Ts plus 1. Then here Ts plus 1. Here 1. Ts plus 1 minus 1. Then what happened? Limit S tends to 0. Ts square divided by S square plus Ts plus 1. S square get cancelled. You have to substitute. Now steady state error is equal to what? Capital T, time constant. In the previous case, in the previous lecture, the error was 0. The steady state error was 0. Here steady state error is capital T. What is the conclusion? What is the inference or conclusion? Okay. So in first order system under unit ramp input, the steady state error is capital T. Capital T is a time constant. For example, if it is a tank system, AR, if it is a electrical system, RC circuit, capital T is equal to RC. If it is a tank, area of cross section and resistance at the wall. So this is the entire dynamics of time response of a first order system under unit ramp input. The equations as well as we got a steady state error also. Okay. Next input is what? What is the next input? Unit parabolic input. Next is unit impulse input. So first I will cover the fourth input. That is what? Unit impulse input. So next question is to find time response of first order system under unit impulse input. So we know the first order system C of S, the first order system transfer function 1 by Ts plus 1, T equal to time constant in second, and R of S equal to 1. What is this? Unit impulse input. So now here C of S divided by R of S equal to divided by 1. You have to substitute 1 by Ts plus 1. Here C of S equal to 1 by Ts plus 1. Here no need of partial fraction because only one term, but we know the Laplace of e raised to at is equal to 1 by s plus a, and Laplace inverse of 1 by s plus a equal to e raised to minus a. Now what I will do? C of s equal to 1 by t divided by s 1 by t. Now I will take a Laplace inverse of C of s equal to 1 by t, Laplace inverse of 1 by s plus 1 by t. If I take C of s equal to C by t, 1 by t, what is this? E raised to 1 by t by t. This is the time response of first order system under unit impulse input. This is what time response of, or only response, especially time response of first order system under unit impulse input. Now we can draw a graph of this. Means unit impulse input is nothing but what? High magnitude of input for a fraction of second, for a shorter period of time. For a shorter period of time. Okay. Now, when t equal to 0, what is the C of t value? Initial value, e raised to 0, that is 1 by t. It starts from 1 by t. When t equal to infinity, after sufficient time, now 1 by t e raised to minus t, that is 1 by infinity, that is 0. So now I draw a graph that is called unit impulse input. Okay, that is 1, fine, and t, and here this R of t and C of t. Now the output starts from 1 by t. Output starts from 1 by t and it goes to here 0. Okay. So when it goes to 0, this is called what? Transient phase. This is called what? Transient phase, because the output goes on changing. Then when the output is 0, that is called steady state phase. So definitely here error, how much is it? Any error, steady state error? Is it showing 0.001 or minus 0.001 or 0? Okay. So now I will find a steady state error also. Steady state error, we know steady state error equal to limit s tends to 0, s r of s minus c of s. This is the formula for steady state error. But here r of s equal to how much? 1, c of s equal to 1 by ts plus 1. So steady state error equal to limit s tends to 0, s 1 minus 1 by ts plus 1. Now limit s tends to 0, that is ts plus 1 minus 1 ts plus 1. So now if you substitute 0 plus 0, 1 divided by 0 plus 1, that is 0 by 1 is equal to what? 0. Here steady state error is 0. Here steady state error is 0. For a first order system under unit impulse input, the steady state error is 0. Okay, this is a response curve, C of t curve, this is a C of t curve, this is R of t, and suddenly whenever you are giving a huge input, that is the output, and because input is for a fraction of second, then the output goes on decreasing and it will become a rest. Suddenly you on the fan and off the fan, so fan is rotating, then after a period of time the fan come to rest. That is what the unit impulse input. I hope you understood both the responses. Thank you.